Hello everyone, this is K. Kranthi Kumar, Assistant Professor in Mathematics of H&S Department of Narasimha Engineering College. This is the video regarding exact differential equations. In this video, we learn the procedure to solve exact differential equations. So these differential equations has so many applications in engineering problems. Okay, this is a definition of an exact differential equation. A differential equation which can be obtained by direct differentiation of some function of x and y is known as exact differential equation. For example, if you consider this one, y dx plus x dy equal to 0. Y dx plus x dy equal to 0. This is nothing but differential of xy. D of xy equal to 0. Okay. If you integrate it, you will get xy equal to c. Okay. So, like this, we'll define the exact differential equation. This is an exact differential equation. Okay. Y dx plus x dy equal to 0 is an exact differential equation. We can define this in this way also. A differential equation of the form m dx plus n dy equal to 0 is said to be exact differential equation if there exists a function of two variables, if there is a function in two variables u with continuous partial derivatives such that it can be written in this form du equal to m dx plus n dy. Okay, if u can be written in this form du equal to m dx plus n dy, then it's said to be exact differential equation. In this case, general solution is given by u equal to constant, where u is a function in two variables here, where c is a arbitrary constant. Okay. Now, look at the necessary and sufficient condition for a differential equation to be exact. Look at the condition. A differential necessary condition. Differential equation of the form m dx plus n dy equal to 0 is said to be exact. Here m is a function in xy and n is also a function in xy. M is a function in xy and n is also a function in xy. So a differential equation of this form m dx plus n dy equal to 0 is said to be exact differential equation. A differential equation is said to be exact if this condition is satisfied. Dou m by dou y equal to dou n by dou x. Okay, if the partial derivative of m with respect to y is same as that of partial derivative of n with respect to x, then we say that this differential equation is exact. Okay, next look at the procedure to solve these exact differential equations. Okay, in order to solve the exact differential equations of the form m dx plus n dy equal to 0, first identify m and then n. First we have to identify m and then n. Next, check whether they are exact or not. Okay, that is verify this condition. Verify whether dou m by dou y is equal to dou n by dou x or not. If this condition is satisfied, then we say that it is exact differential equation. If the differential equation is exact, then this is a general solution. Solution of the differential equation is given by integral m dx. That is, we have to integrate this m with respect to x plus integral of terms in n not containing x. That is, we have to look at the terms in n which are independent of x, and we have to integrate those terms with respect to y, and we have to equate it to some constant n. So solution is given by integral m dx plus integral of terms in n which are independent of x in n dy equal to constant cn. So this is a procedure to solve the exact differential equations. Now look at the problems regarding this. So here they asked us to solve the differential equation of this form. Solve y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x into sine y dy equal to 0. If you observe that the given differential equation is of this form, m dx plus n dy equal to 0. What is m? M is this one, y into 1 plus 1 by x, that is y plus y by x plus cos y. N is this one, n is x plus log x minus x into sine y. Okay, so first we have identified m value and then n value. Next we have to check whether they are exact or not. Find dou m by dou y and dou n by dou x. Dou m by dou y means differentiate this m with respect to y, treating x as a constant. So derivative of y with respect to y is 1. Okay, 1 by x is constant here. Derivative of y is 1. 1 plus 1 by x. Next, derivative of cos y is minus sin y. So dou m by dou y is 1 plus 1 by x minus sin y. Next, dou n by dou x. Differentiate n with respect to x. Okay, derivative of n with respect to x, treating y as a constant. So derivative of x is 1 and derivative of log x 1 by x and minus sin y is constant. Derivative of x is 1 and so dou n by dou x is also 1 plus 1 by x minus sin y. If you observe that both these two are equivalent, dou m by dou y is same as that of dou n by dou x. If these two are equal, we say that the given differential equation is exact differential equation. Okay, if the equation is exact differential equation, general solution is given by integral m dx plus integral of terms in n not containing x dy, or terms in n independent of x dy equal to some constant cn. So we have to consider this m and m is this one, y plus y by x plus cos y, integral y plus y by x plus cos y dx. We have to look at the terms in n not containing x. N is this one, it contains x term, it contains x term, it contains x term. So there are no terms in n which doesn't contain x. Okay, which are independent of x. All the terms contains x. So we have to take a 0. There are no terms in n which are independent of x. All the terms contains x. So we have to consider 0 here. Integral 0 d, which is 0. Now integrate this m with respect to y. Y is constant. Here we are integrating with respect to x and y. So while integrating with respect to x, y is constant. Y into integral 1 dx means x and y, plus integral 1 by x means 1 by x dx means log x and y is constant. X plus log x. Okay, cos y is constant while integrating with respect to x. So cos y into integral 1 dx means x and cos y into x equal to c is the required solution. So this is the required solution. Y into x plus log x plus cos y into x equal to c is the required solution for the given differential equation. Next, look at the second problem regarding this. Here they asked us to solve this differential equation. 1 minus sin x into tan y dx plus cos x into secant square y dy equal to 0. We have to solve this differential equation. If you observe that the given differential equation is in this format, m dx plus n dy equal to 0. What is m? This is m. M is 1 minus sin x into tan y. N is this one. N is cos x into secant square y. So first we have identified m and then n. Next, check whether this differential equation is exact or not. So verify this condition. Find dou m by dou y and dou n by dou x. Dou m by dou y. Differentiate this m with respect to y, treating x as a constant. Okay. So derivative of 1 is 0. Minus sin x is constant. Derivative of tan y with respect to y is secant square y. Derivative of tan y is secant square y. So dou m by dou y is minus sin x into secant square y. Similarly, find dou n by dou x. Differentiate this n with respect to x, treating y as a constant. Treating y as a constant. So here secant square y is constant here. Secant square y is constant here. Derivative of cos x is minus sin x. Derivative of cos x is minus sin x. Okay, so dou n by dou x is minus sin x into secant square y. Now, if you observe that both are equivalent, dou m by dou y is same as that of dou n by dou x. So this condition is satisfied. So we can say that the given differential D means differential equation. Given differential equation is exact differential equation. So if the differential equation is exact, its general solution is given by integral m dx plus terms in n which are independent of x or terms in n not containing x dy equal to c. This is the general solution for the differential equation of the exact differential equation of the form m dx plus n dy equal to 0. Now consider this m. M is this one, integral 1 minus sin x into tan y dx. Now we have to consider this is n and we have to consider the terms in n which are independent of x. There is only one term in n and it involves x. So we have to, there are no terms which are independent of x. So we have to consider those terms. There are no terms, so we have to consider 0. Integral 0 dy. That is nothing but 0. Now integrate this with respect to x n. We know that integral 1 dx is x n. So x you will get here. So while integrating with respect to x, y is constant. So tan y is constant. Minus is here. Minus tan y is constant. Integral of sin x. We know that integral of sin x is minus cos x. Integral 0 means 0 equal to c. So minus or minus will become plus and so therefore x plus tan y into cos x equal to c is the required solution for the given differential equation. Okay, so these are the problems regarding exact differential equations. Okay, if you observe here, you have to learn all the formulas and regarding this differentiation and then integration. In each and every problem, you will encounter these formulas, the formulas in differentiation and then formulas in integration. Here, if you observe that here we are differentiating this. So while finding dou m by dou y and dou n by dou x, we are using differentiation. And if you observe that here we are using integration. Okay, we are integrating here this m with respect to x, and here we are considering the terms in n which are independent of x, and we are integrating them with respect to y n. So we are using both the integration and differentiation. So be careful about this, okay, because we are using both. Okay, learn the formulas regarding this differentiation and integration, then only you can do the problems regarding this. Otherwise, it is very difficult. Okay, here we are using the partial differentiation here. While differentiating with respect to y, we will treat x as a constant because m involves both and x and y. Here we have to use the partial derivatives in order to differentiate this with respect to y. We have to use partial derivative. While differentiating with respect to y, we have to treat x as a constant. Similarly, while finding dou n by dou x, okay, here we have to treat y as a constant. Okay, next here also while integration we will treat y as a constant. Here also while integrating with respect to y, here it is integral 0. But if there is a term here, while integrating with respect to y, we have to treat x as a constant. Okay, so this is the procedure. Okay, thank you.